All right, today's lesson covers the Pythagorean Theorem. We've done this before. You've done it in Algebra 1. We've used it a bunch this year already, so now it's just talking about it in detail. So first off, this is a term you're probably unfamiliar with, a Pythagorean triple. This is a set of three numbers that work in the Pythagorean Theorem. Does anybody know a set of three numbers that automatically work without thinking about it? 2, 4, 6 does not work. 1, 2, 3 does not work. 3, 4, 5 is an example of one of the most common Pythagorean triples out there. What do I mean by it works in the theorem? That means when you take those and you plug them in the theorem, they're equal to each other. So out of these numbers, what do I plug in for C? 5. I always pick the biggest to plug in for C. You've got to make sure that. The biggest, the longest, that goes in for C. So it's 5 squared equals 4 squared plus 3 squared. The order of these two terms does not matter. You could put 3 squared, then 4 squared, or leave it how we have it. 5 squared we know. 4 squared you should know, and 3 squared. 16 plus 9 is 25. 25 equals 25. When these come out to be equal, that means those numbers work in the Pythagorean Theorem. What we're going to learn tomorrow, here's a little preview, is that whenever they equal, that means that you have a right triangle. You have a right triangle. So, we'll be here Tuesday. The other thing to learn is sometimes they won't be equal. And today, when they're not equal, that just means the number is not a Pythagorean triple. But later on, we'll see what it means when they're not equal. So let's look at some examples real quick. Example 1, trying to find the hypotenuse. This is one of the easiest ones. The key thing you should always keep in your head of when to use the Pythagorean Theorem is right triangles. So write that down somewhere. When do you use the Pythagorean Theorem? You have a right triangle and you're missing a side. That's a common time. So when do you use the Pythagorean Theorem? When you have a right triangle and you're missing one side. Here's that case. Example 1 shows it. I've talked about some different setups for problems, but the key thing I emphasized a little while ago is find the biggest or longest side. And in this picture, the longest side is not 24, it is x. It's the hypotenuse. The hypotenuse will always be your longest side. So it's a good habit to label that. Always find that most important piece, the biggest, the longest side. That piece goes in for the C term, always. A common mistake is that people always put x over here, and that would be a big mistake. Sometimes you'll be missing one of the legs, and you've got to remember the legs go over here on the other side. When it's like this, though, it's pretty easy. 7 squared and 24 squared. 7 squared is 49. You may know 24 squared, 576. So add those real quick. 49 plus 576, 625. And that's going to be a nice clean number. How do you get rid of squaring a term? You might want to write that down in case you've forgotten. You square root each side. That gives you the regular x because they cancel. And square root of 625 is, 25. Nice clean answer. So what does this tell us? Whenever you have three clean numbers, three integers that work in the Pythagorean Theorem, it's called a Pythagorean triple. So 7, 24, and 25 is another example of a Pythagorean triple you might see occasionally. That 3, 4, 5 one is definitely the most common, the most frequent one you'll see. So the next part we got to consider are these checkpoints. See what you can do on this checkpoint. You're missing a piece. See if you can plug into our theorem. All right, so checkpoint 1. You should remember that our formula we're using is c squared equals a squared plus b squared. Now, one little thing you might have already noticed, you're probably thinking about this, is A lot of you thought the formula was like this. Well, these are actually the same formulas. But this one can't be used in as many situations as this one. CAB is the one we use, c squared equals a squared plus b squared, because whenever it's not equal, we can look at some other situations. So this one can be used in a lot of other places. That's why I emphasize using CAB. And it also focuses on the most important piece first, the C term, that hypotenuse. Do we know how long the hypotenuse is? Nope, it's over here. There's our longest. I labeled it. Longest goes in for C every single time. And then you plug in the other terms, 9 squared and 12 squared. So I know these pretty well. Whenever we add up 81 plus 144, what do we get? 225. And square root each side, don't forget that. And you get 15. Any questions on that? All right, it's a good problem. Here's a real-life application problem. I've actually used this in real life in different situations, so make sure you really know this. This is probably one of the most important theorems, formulas in math. So learn this one and learn it well. Guarantee it on ACT, every single ACT. It's usually used multiple times. So 6-foot board rests under a doorknob. At the base of the board is 5 foot from the wall. We're trying to find out how high up the doorknob is. So start off with our formula, and I'm going to write it every single time. That way you can see it over and over again. What's the most important piece in that problem? The hypotenuse. Which one's the hypotenuse? 6. That's the piece you have to start with. The 6 goes in for C. It's the most important piece. The others come next. And now you're going to see that now we have the x that's not on the left side. So definitely not always on the left side. 6 squared is 36. 5 squared is 25. Now it's just algebra. We're trying to get x alone. What do we need to move? Subtract the 25. So we get 11. And how do we get x alone? Square root each side. So it ends up being x is approximately 3 point something. What is that? 3 point what? 317. I like how she gave me 3 decimal places. Is it rounded properly? Great. So this is a real life problem though, so I wouldn't be perfectly happy with that answer. Real life problems have units. What are the units on this answer? Make sure to put feet on your answer. There's our final answer. This checkpoint is very similar. See if you can make a quick sketch, label the appropriate pieces, and go from there. All right, here's a basic picture. We have the door, we have the board resting under it. We just need to label our pieces. The board is 5 foot long, and it's 3.5 feet from the door. All right, so here we go. There's that triangle that you should see. If you simplify it, it kind of looks like this. And I'd be happy if you just had this on your paper. We're trying to figure out this height right here. Once again, right triangles. You're missing a side. You have to remember Pythagorean Theorem. What's the most important piece on that picture? The hypotenuse. And which one's the hypotenuse? 5. So I always label that hypotenuse so I know that that piece goes in for my C. And then I can plug in the others. I'll say 3.5 and then h squared. What is 3.5 squared? 12.25. Subtract 12.25. What do you get? 12.75. The last step, square rooting each side. So take the square root of each side. That way these cancel. We're left with h. And on this side, you still get 3.571. And that's approximately equal to, and I need my units, and that's feet again. There's our final answer. All right, here's example 3. Find the area of an isosceles triangle. The sides are 16, 17, and 17. The good news is we have the picture. You don't always have the picture, but this time we do. The key thing that you should probably realize is this bottom piece is a total of 16. But whenever you have an isosceles triangle, it's symmetric. That means the two legs are the same. And that means if this bottom is a total of 16, you can divide it into two congruent pieces. By doing that, you can just focus on half of that isosceles triangle, which kind of looks like this. And then you can use that h in your area formula. So first thing we need to do is use those numbers in our Pythagorean theorem. So I'll use that over here real quick. So what's the most important piece in that picture? 17 is the hypotenuse. It goes first. Always goes first in cab. Following that, we have 8 squared and h squared. So that's 64. What's 17 squared? 289. Thank you. Subtract 64 from each side. You get 225. Square root each side, and you get h is 15. Does that answer the question, though? What's the question really ask for? The area is the key word up here. Find the area. That means you need to know the area formula for a triangle. So you might want to write this down. You should know it. What's the area formula for a triangle? Half times the base times our height. So here we go. We're going to substitute in. How long is our base? Okay, so we're not thinking about just this. We're thinking about the whole thing. And its total base we already labeled, and we were given that. It's 16. Good. And then its height, we just solved for it. It was 15. So here we go. A half times 16 times 15. We get what? 120. And units on this answer. What are our units? Not just meters. Meters squared. Area is always units squared, or square units. So there's our final answer. 120 meters squared. Record that. Now we have a list of a bunch of Pythagorean triples. What they want you to focus on are these bold ones at the top. These top four are the most common. How are these ones below related to the 3, 4, 5? They're just multiples. So if you double them, you get this. If you triple that original, if you times it by 10, it's just showing that these are multiples of 3, 4, and 5. This one is the one you definitely need to memorize. But I occasionally will see the 5, 12, 13 and the 7, 24, 25 on other exams. But this is the number one, 3, 4, 5, that you really need to know. Here's another one real quick. You can use the Pythagorean triples that we just learned about, or you can use the Pythagorean theorem. And this one I probably wouldn't recognize that it's a Pythagorean triple, so I'm okay if you use the Pythagorean theorem. See if you can do it without me. All right. As I assumed, a lot of you are choosing method 2, just using the numbers they give you, not using the Pythagorean triple, and I'm fine with that. So 24 squared is 576, 45 squared is 2025. Add these together, what do you get? 2601. Then we take the square root of that number and we get 51. There you go. All right, here's our last one. Try these checkpoints and then we'll be good to go. All right, here we go on this last couple of checkpoints. The first one says find the area of the triangle. Remember, when you're trying to find the area, it will ask you to find the area of the whole shaded region. So eventually, we're going to have to use our area formula for a triangle. Our problem is that we need two pieces, and we don't have them all. We need a base, we need a height. Currently, we have a base of 28, but we need its height. So we need to find this missing piece. What you should remember earlier was whenever you have an isosceles triangle, you can divide it evenly down that piece and then focus on just that right triangle. So let's focus on that real quick. There's that right triangle. When you chop this piece in half, you're ending up with 14. You still have 50 on the side, and then you're still missing this leg, which is your h, your height. Remember, when you're using Pythagorean theorem, you always start with the longest side first, your hypotenuse, which is 50. And then you can bring over your other terms. So 50 squared is 2,500. 14 squared is 196. Subtract 196 from each side, and you get 2,304. We know how to get rid of squaring a term. The opposite is square rooting. So when I square root each side, I end up with the height is 48. Now I can use that in my formula. 1/2 times the original base, which is 28, times 48 will give me a total of 672. And don't forget your units. Your units can be found over here. They are feet. But remember, whenever you're dealing with area, it's always feet squared. Your last one is nice if you know your basic Pythagorean triples. The Pythagorean triple I pointed out is the most important, or the most commonly seen, is a 3, 4, 5. And you can see that these are probably going to be multiples of 3, 4, and 5. Well, how do you go from 3 to 30? You multiply by 10. Double check here. 4 times 10 is 40. So 5 times 10 will give me my x value. The x value is 50. One last thing I want to point out is that sometimes they will give you problems that have square roots for their terms. So for instance, they'll give you a triangle that looks like this, and they'll say this side is the square root of 36. This side is the square root of 14. And this side is the square root of 26. Maybe they'll have you solve for a missing piece, so we'll do that real quick. Well, sometimes you know the square root value. This one is just 6. But we don't know the square root of this one, so we're actually going to have to do our formula. We're going to have to do CAB. We're going to have to do our Pythagorean theorem, so make sure to always start off with C. It's more versatile than a squared plus b squared equals c squared. Right now we know our longest piece is our hypotenuse, which is across from the right triangle, so that's 6. That goes in for C. Now here's our A and B terms. We'll say our A term is the square root of 26. We're actually going to bring that over with the square root on top of it. Then we're going to bring over our X term. 6 squared is nice, it's 36. But how do you deal with this piece? Well, what you should remember is that squaring a square root, that'll cause them to cancel. And you're just left with a number underneath. So what is our number underneath? It's 26. So I'm going to plug that in right here. And now subtract 26 from each side and square root your answer. So you're left with the square root of 10, which is a little over 3. It's probably 3 point something. So be careful. Remember, when you have a square root, don't be scared. Bring it over because it cancels nicely.